So we've just depolarized the neuron and the cell's pretty uncomfortable. Remember, it's normally at a negative charge and now it's at positive 30. So I always say that the cell is really uncomfortable. It's like if you had eaten too many ions or chips or whatever, you're going to feel full, right? And you're going to want to get that stuff out. That's the same thing that's happening with the cell. We want to get some of those positive charges out. So the next state is called repolarization, which just means that we're trying to get back to a normal value. And instead of using the sodium channel, this time we are going to use the potassium channel. And you'll see that I'm flipping the arrows because we're trying to get stuff to go out of the cell, not back into the cell like we were with the sodium channel. So the cell responds by pushing all of these. It's not really pushing because it's not active transport, it's passive transport, but we're pushing all of the potassium ions out of the cell. Again, not necessarily all of them because they won't all flow through. But when they leave, that will cause the voltage to go back down because we are having negative stuff leave the cell. I'll go ahead and make that line thicker as well and change it to green. So that would be repolarization on your graph. And also now we are probably in between like negative 55 and negative 70 millivolts. This part can kind of change depending on what happens. But something that does happen, well, let me get back to this first. So specifically during repolarization, what happens is the sodium channels close because sodium channels and potassium channels are mutually exclusive. They can't be open at the same time. That's the function of another protein that we'll talk about later. So the sodium channels are going to close, the potassium channels are going to open, and then potassium is going to rush out of the cell because remember the cell was uncomfortable. And so go ahead and pause the video, make sure that you have this written down, and then come back. So now that you've written down repolarization, I wanted to talk about this next state, which is called hyperpolarization. And just like hyper means overly polarized, or hyper means overly active, this just means overly polarized. And so what can end up happening is additional potassium ions can flood out of the cell because the cell's freaking out so much, like I gotta get this potassium out. It's way too negative, or way too positive. So a bunch of potassium ions can flood out. And when that happens, we can actually push too many potassium ions out. And we go into this state called hyperpolarization where we're actually more negative than we normally would be, which is the negative 70 millivolts. So go ahead and take notes on that as well. Hyperpolarization is the specific state when too many potassium ions have left the cell.